Deriving Bernoulli's equation, we made the following assumptions. We had steady flow. We assumed that we could neglect friction, so non-viscous or inviscid fluid flow. We also have no work being done on the fluid. We have no heat transfer to the fluid. And this is analogous to work here. We have incompressible flow. And we have that the flow has to be along a streamline. So those restrictions limit our application of Bernoulli's equation. However, in this case, we can make one simplification. Usually this constant can vary for different streamlines. Unless the fluid flow is what's called irrotational. And for that we can briefly illustrate the difference between irrotational and rotational flow using the figure at the bottom right here. Irrotational flow is flow that we usually get when there's no effects of viscosity, and so in this case the fluid particles will not rotate as they pass through the flow domain. Rotational effects will happen close to the boundary where viscosity is very important, and so in that case viscosity will cause our fluid particles to spin. Whenever we have non-viscous flow, we can assume that the flow is generally irrotational, and therefore the constant will be the same for all streamlines, and so therefore we can oftentimes neglect the requirement that flow is along one specific streamline. And so the key assumptions here for the application of the Bernoulli equation are steady flow, inviscid flow, and incompressible flow. And when those three assumptions are not held, we should not be applying Bernoulli's equation to a problem.